Right, this graph is a bit more complicated, it's a bit more complex. What you've got here is velocity, we'll call that meters per second, and we'll call this one time in seconds. Okay, the units of seconds that I'm using. Right, so it starts off at 0 meters per second, it goes up, velocity is increasing up to 60 meters per second. And that's taking 10 seconds. Now you can work at the gradient of that line, that will give you the acceleration, or you can use the formula, right, which I'm going to use now to work at the acceleration. So you can use work at the gradient, or you can just work at the acceleration using the formula. So this is part one. We'll just call this one part one. Right, there are 4 parts to this journey. You'll see in a moment. Part one, we use v minus u divided by t to give you the acceleration. Final velocity there is 60. And the initial velocity is 0. And the time it took to get from 0 to 60 meters per second, it took us 10 seconds. So that's 60 take away 0. 60 divided by 10 is 6. So acceleration is 6 meters per second. I've explained that unit, how this unit works, in a previous video. Right, for the next journey, we are going from here to here. All right. You can see the velocity is constant. There's no acceleration. We'll call this one part 2, and I'm going to show you the calculation. I'm going to prove to you that the acceleration is 0. So for part 2, just do it over here. Acceleration is v minus u divided by t as usual. Final velocity right there is 60. Look, 60. And the initial velocity for this part of the journey is also 60. And the time taken to get from this point to this point here, it's taken 5 seconds. So 60 taken from 60 is 0. 0 divided by 5 is 0. Right, so the acceleration is 0 meters per second. There's no acceleration. The gradient is obviously 0. Right, the next part of a journey, we start here and we're going to finish here. Right, that's where we're going to apply our formula. We'll call this one part 3. Right, the final velocity is right here. That refers to negative 40. Final velocity is negative 40. And the initial velocity right here, it's 60. And the time it's taken to complete that part of the journey, we started here and finished here. So that part of a journey, right, we started here and we finished here. That's taken how many seconds? 5, 10, 15, 20, 25 seconds. So if you work that out, negative 40 take away 60 is negative 100 divided by 25. Right, that's going to be negative 4. Because it's slowing down, it's decelerating. That's negative 4 meters per second. Right, this part here is interesting. I'll talk about that in a moment. In fact, I will show you a little video to illustrate that, what happens here. Right, for the last part of our journey, we'll call it part 4. This bit we'll call part 4. It will be a positive gradient, right, because it's going uphill. Well, it's going up, the graph is going up. The final velocity there is referring to 0. And the initial velocity right there is referring to negative 40. And the time taken to get from here to here is 15 seconds. So that'll be 0 take away 40. That'll turn into a positive, wouldn't it? That's 40 divided by 15. Need a calculator for that. 40 divided by 15. 8 over 3, 2.6 recurring. If you want that as a decimal, you can leave it as a fraction if you want. 2.6 recurring, that's my acceleration, meters per second per second. Okay, there are 4 parts to this. That's why I've had to use that formula 4 different times. You cannot use that formula for the entire journey. Do not say, for example, this is wrong, right? Oh, we're going to do it for the entire journey. So at the very end, it becomes 0. And at the beginning, it was 0. And it took 55 seconds. Therefore, for the entire journey, it's 0 divided by 55, 0 meters per second. That does not make sense, right? You have to apply that formula, v minus u divided by t, for each of the parts of the graph. Now, what I want to show you is what happens over here at this particular point, because you can see where part 2 finishes, part 3 begins, right there. The velocity, it's slowing down. Slowing down, and then it becomes 0, and then the velocity starts becoming negative. I want to show you what exactly happens at this point over here. Please watch the video. So now I'm going to explain to you what happened. So that came running, and then I slowed down, and then I came to a standstill. And then from standstill, I slowly started going backwards and slowly increasing my speed. That point here refers to this over here on my graph. So as you can see here, slowing down, my velocity slowing down until I came to a standstill, but then I started going backwards now and slowly increasing my velocity backwards. So really this point over here, the standstill bit, refers to this big yellow dot on my graph.